Pumps are vital to the operation of a refinery or a chemical plant. Without them, we could not operate. Therefore, it is important that they stay in operation and that they are operated safely and efficiently. What does a pump do? What does it do that makes it such an important piece of equipment? Nearly all the materials handled in a refinery or a chemical plant are at one time or another in liquid form. They have to be moved from one place to another, and this is what a pump does. Moves liquid from one place to another. For example, pumps move feedstocks from tank to tank, or it may be products like gasoline or alcohol. Sometimes a feed system requires moving liquid from a feed tank through a furnace to a tower. Products from an operating unit must be pumped to a product tank. In order to move the liquid, the pump must add energy. A pump moves liquid from a lower level to a high level. A pump moves a liquid from a low pressure, such as in a feed tank, to a high pressure, such as in a tower. Or the pump may need to overcome line friction or resistance, as in moving liquid from a tower to a product tank. From these illustrations, we can conclude that a good definition of a pump is: a pump is a mechanical device which adds energy to a liquid for the purpose of moving it. Let's repeat. A pump is a mechanical device which adds energy to a liquid for the purpose of moving it. Now open workbook number 2 to the instruction sheet. Read the instructions carefully and then complete exercise 1. Ask the instructor for help if you need it. Now let us look at what you will learn in this course. You will learn to recognize different kinds of pumps by sight. You will learn to identify the major parts of pumps and to explain how they function. These parts have such names as impeller, cylinder, suction and discharge valves, seals, packing, wear rings, volute, casing, water jacket, bearings, lubricator, oil reservoir, oil rings. Shaft, piston, plunger, diaphragm, screw, gear, and lobe. You will learn the meaning of common pumping terms and how to use them in solving problems. Terms like suction head, discharge head, total head, and NPSH. RPM, stroke, liquid horsepower, brake horsepower. Efficiency, pump capacity. And pump characteristic curves, sometimes called performance curves. Open workbook number 2 and complete exercise 2. In this course, you will learn to describe how a centrifugal pump operates. To do so, you need to know more than the fact that the liquid comes in here and goes out there. Water spinning from the rim of a turning wagon wheel is a good example of centrifugal force in action. Understanding this principle makes it relatively easy to visualize the operation of a rapidly spinning impeller in a centrifugal pump. When you have learned the basic parts of the pump and understand the functions they perform, describing how a centrifugal pump operates will be relatively easy. You will also learn to describe how a positive displacement pump operates. Of the many types of positive displacement pumps, you will learn the most about the steam reciprocating pump. You will learn the effect of operating pumps in series, which is somewhat like tying two ropes together. While operating in parallel is somewhat like having two men working alongside of one another. Liquids have different specific gravities. Some are lighter than water, some are heavier. You will learn the effect of specific gravity on pump head and power consumption. You will learn the effect of closing the discharge valve while the pump is in operation. And what happens if you try to operate the pump with the suction valve closed or partly closed. As you learn more about pumps, you will learn to recognize and correct some common operating problems. You will learn the importance and purpose of proper lubrication, the necessity for water cooling, and the need for seal oil. You will understand the need for check valves and for safety valves. For both centrifugal and positive displacement pumps, you will learn to describe and perform startup and shutdown procedures. Open workbook number 2 and complete exercise 3.